Hey everyone, welcome to lesson 4 of our quadratic functions unit. We began this unit last week where we started to talk about the differences between linear functions and quadratic functions. We talked about the features of a parabola, and you started to learn how to graph a parabola by learning about something called vertical translation. And I'm going to continue with that topic. But before I start our lesson for today, I want to review some of the main concepts from last week. So the image that you see in front of you is that of a parabola. A parabola is this curved shape, looks like the letter U. The first thing I want to talk about is the vertex, and the vertex is the topmost or bottommost part of a parabola. So in this example over here, this point right here is our vertex, and we would say it occurs at -1, comma, -4. There are also two x-intercepts in this parabola, and an x-intercept of a parabola is just where the parabola crosses the x-axis. So -3, x is equal to -3 would be one x-intercept, and x is equal to 1 would be the other x-intercept. We also learned about the axis of symmetry, and the axis of symmetry is basically a line that's drawn to split the parabola into two to make it perfectly symmetrical. And you can see that with this green line over here. And we would say that the axis of symmetry in this example is x is equal to -1. A few more descriptions that we can use for this parabola is, does it open up or down? Clearly, this parabola is opening upwards. And when a parabola opens up, we say it has a minimum. So a parabola that opens up has a minimum value. Another example would be a parabola that opens down, which would have a maximum value. All right, so the next concept that I want to review is how to graph a parabola, a parent function parabola. So that's something that has an equation of y is equal to x squared. Now, in the past, we've learned that we can make table of values and make x and y and graph them that way, but it's not very efficient when we're graphing parabolas. Rather, we want you guys to be using a step pattern. And the step pattern that we use for a parabola is 1, 3, and 5. So you begin with the vertex, you go 1 to the right, up 1, 1 to the right, up 3, 1 to the right, up 5, and you do the exact same thing on the other side. So the very first transformation that you guys learned about last week was something called vertical translation. And vertical translation basically means we are moving up our parabola either up or down. We always begin with our parent function of y is equal to x squared, and then we are going to be adding a number after that. So if you have a plus sign and then the number, it means your parabola will be moving up. If you have y is equal to x squared minus a number, that means that parabola is going to be moving down. So if you take a look at the three examples I have here, the blue parabola is our parent function, y is equal to x squared. Let's look at the example up here. Y is equal to x squared plus 2. So that means that I will be moving my parabola up 2. And you can see that if this was our original vertex, this has now moved up 1 and 2 units. So all we did is we shifted, or we vertically translated our parabola up 2 units. The other example I have here is y is equal to x squared minus 2. Minus 2 means our parabola will be moving down 2 units, or vertically translating 2 units. The mathematical language is very important. You want to be using, you don't want to just say it moves up, moves down. You want to say vertically translated 2 units. So again, our original parabola was right over here, and then you go 1, 2, down 2 units. So your vertex has now moved down. All right, we are finally ready to get into our new lesson. So remember, what we're going to be doing is we're going to be taking our original parent parabola, and we're basically going to be shifting it around. We're either moving it up or down, side to side, flipping it over, stretching it, compressing it, and that's basically all we're doing. So we've already learned how to move the parabola up or down. The next transformation that we're going to learn about is something called reflection in the x-axis. And what that's going to look like in your equation is there's going to be a negative sign right in front of the x squared. So as soon as you see the negative sign, you should recognize that your parabola is going to flip over, and instead of looking like a U, it's now going to look kind of like an N. So what does that mean for us? Well, let's take a look at example number 1. Y is equal to negative x squared. In this example, our parabola is not moving up or down. There's no number after the x squared. It's not moving side to side. So our vertex is going to start at 0, 0. And you always want to begin with the vertex. Okay, now generally what you do is you go 1 to the right, up 1, but because there's a negative sign and there's a reflection in the x-axis, we're still going to have a step pattern of 1, 3, and 5, but this time you're not going to be moving up, you're going to be moving down. So what you're going to do is starting from the vertex, you're now going to go 1 to the right, down 1, then you're going to go 1 to the right, down 3, then you're going to go 1 to the right, down 5. 1, 2, 3, 4, 5. And you're going to do the exact same thing on the other side. Starting from the vertex, 0, 0, you're going to go 1 to the left, down 1, 1 to the left, down 3, 1 to the left, down 5. And then once you have done that, you are going to make a nice smooth curve. Put an arrow. Do the same thing on the other side. Put an arrow. And don't forget, every single one of our parabolas needs to be labeled with the function. So this is going to be labeled as y is equal to negative x squared. And that's what a reflection in the x-axis looks like. It's just a parabola that's been flipped over upside down. Let's look at example number 2. In this example, we actually have 2 different transformations, so we have to be careful. I see a negative sign, so I know my parabola is not going to look like a U, it's going to look like an N, it's going to be flipped around. And I see a positive 2. So let's begin with that. We've learned that a plus 2 means it's a vertical translation 2 units up. That means our vertex is not going to be at 0, 0, it's going to be at 0, comma, 2. Always begin by writing down the vertex because that's going to be your starting point. So we've now dealt with the plus 2. We know our vertex moves up 2. The negative sign tells me that the parabola, we're not going to be going up 1. We're going to actually be going down 1. So our step pattern is still 1, 3, and 5. Start with the vertex. You're going to go 1 to the right, down 1. 1 to the right, down 3. 1 to the right, and down 5. Oh, I don't like how that looks. 1, 2, 3, 4, 5. We're going to do the same thing on the other side. 1 to the left, down 1, 1 to the left, down 3, and 1 to the left, down 5. Okay, step back. You should be able to see the curve that you are trying to make. So now draw a nice smooth line connecting all the points together and make an arrow. Another nice smooth line connecting all the points together, make an arrow, and then label it y is equal to negative x squared plus 2. Okay, our third transformation is a horizontal translation. So as the name suggests, a horizontal translation means our parabola is going to be moving side to side. And what that's going to look like is you're going to have a number inside the bracket. So it's going to look like this: x plus a number, all of it squared, x minus a number, all of it squared. Now, because of the last unit, as soon as you see this, you might be tempted to FOIL and expand and do all sorts of stuff, but don't do that. We want it to look in this format. We want a binomial inside the bracket, all of it squared. It's a little bit counterintuitive though. If the number inside the bracket is a plus sign, you are actually going to be moving to the left. And if the number inside the bracket is a minus sign, you are going to be moving the parabola to the right. It takes a little bit of practice or just a little bit of thinking to remember that, but you'll get the hang of it with more questions that you do. So let's look at example number 1. Example number 1 says y is equal to bracket x minus 1, all of it squared. I know that when I have a number inside of the bracket with my x, that is a horizontal translation. And because the number is negative 1, it means I am going to be moving 1 unit to the right. So the way that you would use words to describe this is it's a horizontal translation 1 unit to the right. And we are going to have a lesson where we talk about just the words and the language in a bit. Now, what about the vertex? There's no number that follows after. So we know our parabola is not moving up or down. It's staying on the axis. There's no vertical translation, but you are moving the parabola 1 unit to the right. So that means our vertex is going to be 1, comma 0. So always begin from the vertex. And now there is no vertical translation. There's no reflection because there's no negative sign in front of the bracket. And so our step pattern is going to be 1, 3, and 5. And we're going to do this the good old fashioned way. So we start at the vertex. We go 1 to the right, up 1, and make a point. 1 to the right, up 3, make a point. And 1 to the right, up 5, make a point. And do the same thing on the other side. Step back, you should be able to see your curve and draw a smooth line connecting all of the points. Put an arrow and don't forget to label. Y is equal to x minus 1, all of it squared. And we would say this parabola has a horizontal translation 1 unit to the right. Let's look at example number 2. Now, I'm trying as we are getting progressively learning more translations, I'm trying to give you examples that have a little bit of everything. So for example number 2, this is the first example you've seen that's a little complicated because now we have 3 different transformations. The first one, I see a negative sign. So that means it's a reflection in the x-axis, and our parabola is going to flip over and open downwards like this. Then I see there is a number with my plus inside the bracket, x plus 2, and that means my parabola has a horizontal translation 2 units to the left. Counterintuitive. A plus 2 actually means you're moving 2 units to the left. And then finally, I see a positive 1, and that means it is a vertical translation 1 unit up. So our parabola is going to be moving up 1. Always begin by figuring out the vertex. So usually we begin at 0, 0, but now our parabola is going up 1 and it's going 2 units to the left. So our starting point is going to be up 1, 2 to the left, right over there. And we're going to go ahead and write our vertex, which occurs at negative 2, comma 1. We still are using our step pattern of 1, 3, and 5. Now you're going to notice I gave you a little bit of a hint because I gave you a graph where you can't possibly go up because I know if there's a negative, it's a reflection. It has to go down. So when we start to draw our points, you guys hopefully are getting used to this. Start at the vertex. You're going to go 1 to the right, down 1. 1 to the right, down 3. 1 to the right, down 5. 1, 2, 3, 4, 5. Do the same thing on the other side. Down 1, down 3, 1, 2, 3, 4, and down 5. And draw a smooth line connecting everything. Arrow. And let's label it y is equal to negative x plus 2 squared plus 1. So 3 transformations. We had a reflection in the x-axis. We had a horizontal translation 2 units to the left. And we had a vertical translation 1 unit up. We are on to our very last transformation. This is transformation number 4, and I saved the best for last, vertical stretch and compression. The way that you recognize a vertical stretch or compression in an equation is that you're going to have a number in front of the x squared. Okay, and there are 2 different scenarios. If the number is greater than the number 1, you are going to have a vertical stretch. So 1, 1.5, 2, anything that's over the number 1. And if you have a number between 0 and 1, so that means it has to be a fraction of some sort, that is going to be a vertical compression. So the first thing you do is first you identify, well, yeah, I have a number in front of x squared, so it has to be a stretch or compression. And then you think about what the number looks like. If it is a fraction, it's going to be a compression. And if it's a number over 1, it's going to be a vertical stretch. Now, the way I like to think about this is I like to think of it as having a balloon. Okay, so let's imagine this little oval over here is a balloon. And if you take your balloon and you hold it from the top and the bottom, so you hold it here and here, and you stretch it. So vertical stretch. You're stretching it vertically up and down. What's going to happen to that balloon is it's actually going to become narrower. Okay, so imagine and visualize yourself holding a balloon from the top and the bottom, and you now stretch it from the top and the bottom. And when you do that, your balloon is going to elongate and become narrower. That's exactly what happens to a parabola that is vertically stretched. So in this example over here, the blue parabola is y is equal to x squared. It's your parent function. And then if you add a 4 in front of it, so y is equal to 4x squared, that's a vertical stretch. When you graph that, you're going to notice your parabola is actually narrower than the original parabola. And I'm going to show you how to graph it in the next slide. Let's look at a compression and see what that looks like. So again, a compression is when the number in front of the x squared is a fraction between 0 and 1. Let's go back to our balloon example. And again, you're holding it at the top and the bottom, but this time you're not stretching it, you are compressing it. So you're pushing the top and the bottom in. And if you can visualize that balloon, if you were to hold it from the top and the bottom and you were to compress it, what's going to happen is your balloon is going to become wider. And that's exactly what happens to a parabola when there is a vertical compression. So let's look at this example over here. In the blue, you have y is equal to x squared. That is your parent function. And when we have a vertical compression, you're going to notice that that parabola actually becomes wider. Y is equal to a half x squared. The parabola has now become wider. So in a compression, our parabola is wide, and in a stretch, our parabola is narrow. Okay, so let's look at example number 1 over here. We have y is equal to 2x squared. I have a number in front of the x squared, which means we are dealing with a vertical stretch or compression. Because this number is greater than 1, we know it has to be a stretch. And when we have a vertical stretch, remember, our parabola ends up being narrower than the parent function y is equal to x squared. Where is our vertex going to be? Well, there's no number in front of the x with the x, so there's no horizontal translation. There's no number after the x squared, so there's no vertical translation. Our vertex is going to be at 0, comma 0. Now, how exactly do we deal with a vertical stretch or compression? Well, the trick is you need to start by looking at our original step pattern of 1, 3, and 5. And all you do is you take that step pattern and you multiply it by whatever number is in front of the x squared. So in this case, we have a 2, which means we're going to multiply each of these by 2. Our new step pattern is going to be 2, 6, and 10, and that's what you use to graph your parabola. Okay, so let's begin by graphing our vertex at 0, 0. So there's going to be a point right there. Now, there's no reflection, so we're going to be moving up. We're going to go 1 to the right, and we're not going to go up 1. Now we're going to go up 2. Then we're going to go 1 to the right, and we're going to go up 6. 1, 2, 3, 4, 5, 6. And that's all I can fit on the graph. That's okay. With these vertical stretches, sometimes you're not going to be able to fit too many points. As long as you have 5 points, that's good enough. So I have 3 over here, and now I'm going to go to the other side. I'm going to go 1 to the left, up 2, and then 1 to the left, up 6. 1, 2, 3, 4, 5, 6. And that is all we need to graph our parabola. Now, it's not clear to us that this parabola is actually narrow, but if we were to graph our parent function y is equal to x squared, you would notice that this parabola is narrower than a traditional y is equal to x squared graph. So the way that we would describe this in words is we would say this parabola has a vertical stretch by a factor of 2. Okay, so example number 2, y is equal to 0.5x squared. Clearly, this is going to be a compression. And I know it's a compression because the number in front of the x squared is between 0 and 1. And so our parabola is going to be wider than our traditional y is equal to x squared parent function. Again, the vertex is going to be at 0, comma 0 because there is no vertical translation and no horizontal translation. This parabola isn't moving anywhere. It's staying right there. It's just getting a little bit wider. Start with your step pattern of 1, 3, and 5. And now you're going to be multiplying those numbers by 0.5. Okay, and when we do that, 1 times a half is going to be a half. 3 times a half is the same as 1 and a half. And 5 times a half is 5 over 2, which is 2 and a half. So our new step pattern for this example is going to be a half, 1 and a half, and 2 and a half. Okay, so we're going to start at our vertex, which is 0, 0. We have to be very careful with this because you are graphing halves. And honestly, these are the hardest types of questions we're going to give. We're not going to give anything crazy like a third or an eighth or a sixth because those are impossible to graph. So we're going to go one to the right and we're going to go only up a half. Then we're going to go one to the right. We're going to go up 1 and a half, which should take you to the number 2. Then you're going to go one to the right and go up 2 and a half. So 1, 2, a half. So same thing on the left. You're going to go one to the left, up a half, one to the left, up 1 and a half, one to the left, up 2 and a half. And then you're going to graph these lines. While I'm graphing, I'm going to just let you know that the calculations I did on the side, always change it. Like if you end up with a number like 3 over 2, that's not easy to visualize. You always want to put it into a mixed fraction so you can see clearly what the whole number is and what the fraction is. So this is going to be y is equal to a half x squared. Leave it as a decimal or fractions up to you. The way you would describe this is this parabola has a vertical compression by a factor of a half. All right, we have finally reached the end, and now we have an example where we have every single transformation put together. So we've learned 4 of them. Let's do them in order. This equation has y is equal to negative. That negative sign means I have a reflection on the x-axis. My parabola is going to be opening downwards. Then I see the number 2. That tells me that I have a vertical stretch. That means my parabola will be narrower. And if I take my step pattern of 1, 3, and 5, I know I have to multiply 2 to all of those numbers. And my new step pattern is going to be 2, 6, and 10. I also see I have x minus 4, and that x minus 4 means I have a horizontal translation where I'm going to be moving 4 units to the right. And then finally, we have a plus 6. That means I have a vertical translation and I am going to be moving 6 units up. Okay, so we're going to begin with our vertex. To find our vertex, we only really need to be looking at these 2 pieces of information. So we're going to be going up 6 and 4 units to the right, which means our vertex is going to be at 4, 6. Now, I know that we have a reflection, so we're going to be going down, and our step pattern is 2, 6, 10. So starting at that vertex, I'm going to go 1 unit to the right. You always only move 1 unit to the right, and then you're going to go 2 units down. Then another unit to the right, and this time we're going 6 units down. And then unfortunately, we can't fit the last point because it's 10 units down, so I'm just going to ignore that one. Then again, back to our vertex, we go 1 to the right, 2 units down, 1 to the right, 6 units down. And that's the most we can fit on our graph. We're going to make a smooth line, connect all the points, arrow, and finally our equation is y is equal to negative 2 x minus 4 squared plus